We're back for another stream. We're gonna do a bunch of stuff today around looking at Twitter Snowflake IDs, which is a method of generating unique identifiers, and it's what Twitter uses for its tweet IDs. It's a pretty cool idea, and I thought we'd have a look at it and maybe create a very small microservice API to generate those IDs. It does need a microservice API. It's a bit of a complicated way to generate an ID, but it's a globally unique identifier, a bit like a GUID, but has some advantages over a GUID as well. So we'll have a look at those. There's some news as well. We'll have a look at some news, and let's crack on. So I'll switch over to my desktop. Today, the first bit of news is Andrew Locke has got a new blog post about the iLogger stuff that we looked at in an earlier stream. Do go have a look at the ASP.NET Core stream. He talks about using the source generated logger message attribute and so on. And he does something I didn't do, which is wrote a benchmark looking at some of the performance, and he covered one or two other things that I didn't cover, whereas I was just kind of doing an investigation. One or two things that in my stream that were worth looking at also. So if you want to read something in text form, I'd definitely take a look at this. Another big piece of news is Microsoft released this thing called Azure Container Apps, which is a way you can deploy microservices using Docker containers. It's actually built on Kubernetes, but hides all of the kind of complexity of Kubernetes away. It's early days. I had a quick look at it. I read all this documentation. There's not much here at the moment. But it seems like it's early days. So what I discovered was you can deploy one or more containers in a pod, but you can also do multiple pods, but the format for that is a bit it's not great. So right now it's a CLI like this, or you can so this deploys one container using this image and exposes it externally to port 80. And then you can run another command to expose another container app, and they can talk to each other. But the thing that I really would like is to be able to use a Docker Compose file or even a Docker Swarm file in YAML and just have that automatically get deployed, and it does all the scaling and everything for all of the different microservices in the YAML file, scales them up when they're needed and scales them down when they're not needed, automatically connects them up so that they talk to each other using DNS, so you don't need to kind of mess about changing your application in any way, shape or form. So I raised a GitHub issue over here in the Azure Container Apps Issues 2 repo. So I'm just going to stick that in the chat. So do have a look at that. Do give it a like. Hopefully they'll implement this, and then we'll have a really easy way to deploy a set of microservices and get them to scale. Because right now the only way to do that easily is using something like Azure App Services, but then you have disadvantages there because you're using IIS. Azure Container Apps uses Envoy as a proxy, which is it will work with things like Google's gRPC, and whereas Azure App Service won't. And then also there's a bunch of other improvements as well. So you can scale down all the way to 0 containers, which is interesting. It's easy to hide a container and not expose it publicly. It seems like a really nice Azure service, and I'd probably use this if I was going to host something now. Hopefully they add Docker Compose or Swarm support, and it makes it even easier to deploy something. So that's the bit of news I had for the last couple of weeks. Let's switch over to talk about Twitter IDs. So if you go over here to the Twitter docs, they talk briefly about the way they generate IDs. So if I just go to, I don't know, go to a tweet, I will pick, I'll go to my Twitter and we'll just pick any old tweet. This one. You can see that they've got a whacking great big number over here. That's actually a Snowflake ID, what they call a Snowflake ID. The idea being, of course, that every snowflake is unique. So this is also unique. Every Snowflake ID is unique in the world, so it's globally unique. And that has some advantages. So for example, normally, if you were to write a database, kind of a relational database, you'd have like a customer table, and then you'd have some sort of list of customers, and they'd have incremental numbers going up 1, 2, 3 for the column ID, and maybe you'd have an order ID, and you'd have a set of orders, and they'd be connected using some sort of relationship. The issue with that is multiple. So first of all, you shouldn't be exposing your unique IDs publicly through your API, ideally. So you'd need to create some sort of other unique ID, and typically that can be a GUID generator. We'll just grab, that's nice. DuckDuckGo generates one for you. That's nice. So typically you'd have another kind of column in your application, and you might use a GUID. A lot of people use GUIDs to generate IDs, and maybe they'd be slightly different. So, they'd have slightly different GUIDs, and then you'd have to generate GUIDs here as well. And then you can expose these publicly, but when you want to work internally with the database, you'd have to use these identifiers. So it's a bit of a mess. Also, you have the problem if you expose your incremental identifiers here, that somebody could, I think it's called, it's insecure basically. Somebody can attack you by just if they knew that their user ID was 2. Say I'm Bob, I'm going to the website, I have a user ID 2. I could change my user ID to 3 and try to hack something, or see if some endpoint is open, and I can see if I can get hold of Fred's data. Whereas if something was a GUID, they wouldn't be able to do that. They wouldn't know what Fred's GUID was. So it's not like a completely secure way of doing things, but it's just a kind of a defense in depth approach, where you just give potential hackers additional hurdles that they have to kind of run over or jump over, and protect your API in depth. So that's another reason why using sequential identifiers is not a good idea. So that brings us on to Snowflake IDs. So Twitter kind of coined the term, and they're essentially longs in the int64, so 64-bit integers. So there are issues with trying to fit a globally unique identifier into an int64, because the number can be too small for if if you have a really large scale application like Twitter or Facebook or someone like that. So they needed massive scale, and they needed an identifier that was nice and small, compact, because they want nice URLs. You know, your URL is part of your user experience, and if you don't have nice URLs, if you had a whacking great big GUID in here, if it looked like that, that would turn people off, I think, a little bit, trying to maybe type in the URL box. I guess a lot of users don't type in the URL box anymore, but I think it looks nice. There are other ways of doing this, of course. You could go with alphanumerics instead. So you could go with, the odd letters over here, and that would give you more combinations. But then it wouldn't fit into an int64. There are advantages to having a pure int64 as opposed to a string here as an identifier, and that's mainly because you want to be able to store things efficiently in a database and have the identifier be sequential. So I talked about not having something sequential, but you do still want numbers that are sequential in a temporal manner, temporal way. So older tweets have a smaller ID number compared to newer tweets, but there's a kind of a gap in between, and that gap could be anything. So if we refresh that, so if I look at a couple of different tweets over here, here's a newer tweet and here's an older one, and if I look at the older one and the newer one, so the newer one is at the bottom and it has a slightly bigger number here, so there's a 3 here as opposed to a 1, and that is really nice because if you're storing that in a database, you can index this column and have it be really efficient to query back and forth and pull things out of the database by ID. So that's another reason why these Snowflake IDs are a really great idea. This is a really old blog post by Twitter a long time ago. They wrote about these Snowflake IDs, and they actually had a Git repo where they implemented Snowflake IDs, and it was written in Scala, and it's now a public archive, but you can go to a particular branch, I think it's Scala 28, and you can go and look at the source code. I think it's, they had multiple implementations. I think I looked at the Scala one and I migrated it over to .NET, which was, I hadn't ever seen any Scala before. So is it Scala or Scala as well? That's a good question. I hadn't seen any of the Scala or Scala before, so that was an interesting task, having to go and migrate that over to a .NET project. And I have a Snowflake ID project or class, and I'm just gonna new up an instance of Visual Studio, stick that into a project, and see if we can, that's the wrong window, see if we can, it's the wrong window again, come on, try again, sorry, create a new project. We'll just create a quick class library, make this a bit smaller so I can actually fit on my screen. Next, and we'll call this ID. That'll do for now. .NET 6, of course. So I have my Snowflake ID class, And I thought we'd just kind of talk through the code a little bit because it is complicated. And I'm just going to drag it in. There's my Snowflake ID class. And we'll also add another project for a unit test project. XUnit. I already have one over here. Let's pin that because I use that a fair bit. XUnit, and we'll call it id.test. And we'll write some tests for this in a minute. We'll call this test Snowflake ID test and rename the class as well. Rename file. There we go. So let's have a look at the class. There's actually two classes in here. I should probably pull this out into a separate file. There we go. And we'll have a look at that in a moment. There's some options for your Snowflake ID generator, and this is the actual generator class over here. Doing some funky logic. It's not too long. It's only about 125 lines of code, and we can pass in some options into our Snowflake ID constructor. I don't think I used the options class yet, actually. I think I was gonna switch over to it, but I never got around to it. That's my fault. For now, we'll ignore the options class then. So how do we use this thing? So, well, let's write a test and I'll show you. So, var Snowflake ID. It's really a generator. I should probably call it a generator. Snowflake ID, because it's not a single ID. It's a generator. So maybe we should Snowflake ID generator. And I'll rename the file as well. And we'll just call that Snowflake ID generator. And is it gonna add a reference? Yep, that's nice. And we'll new one up. And this is where we provide a date time. We'll come on to why in a second. Loading suggestions. Are you gonna help me? There we go. Dot now, UTC now. Don't think it matters. I would use UTC now. We'll do a worker ID of 0, a data center ID of 0, and we'll start with a sequence of 0. And we'll just call, what's the function to generate? I think it's next. And that gives us our ulong. Dot. What can we assert? Let's pass in a particular date for now, so that we can actually write a test that makes sense. So let's say 2000, the year 2000, first. Stick that in there. Cert dot equal. We have no idea what that's going to generate, but we'll just call it 0 for now. And oh, not date. That's Snowflake ID. So we got our arrange, act, and assert. I don't really know. Some people add comments like this. I don't see the point of that. I think it makes the test a bit noisy. I prefer to just use a blank line. Nice and simple. Cannot convert from ulong to string. What? That's not a string. Why does it think it does it not have a ulong overload? Assert.equal? That'd be very interesting if it didn't. Assert.equal. High numerable t. Yeah, that should work. That's strange. Let's build that and see if that works. Int to string. What? I don't know what the actual shortcut is for a ulong. Is it u? Uint 32. What's the uint 64? There we go. ul. That was a total guess. Let's try running that test. And in fact, we'll run live unit testing because it will be useful. Did that work? That didn't work, of course not. We didn't stick in the ID there. So that's the ID we got there. And hopefully, now that we run live unit testing, it will go off and test that for us. And we'll get something that is repeatable. Actual. Come on. Is it generating different IDs each time? Even though I gave it a particular date. That's strange. Oh, this is expected. This is expected. It's adding time to this date time. So depending on how long these lines of code take, it's gonna be, yeah, that's not a great test. The way this works is you give it an epoch date, and that's basically your start date when you want to start generating IDs from. So this Twitter will have used whenever their API went live. Then you give it, I'll come on to these IDs in a minute. You give it a sequence number to say where do you want your sequence to start. And after that, it will add, when you want to generate an ID, it will add the number of milliseconds that have elapsed from the epoch. So datetime.utc now minus the epoch, total milliseconds. And it will use that timestamp effectively to generate a new ID over here using this kind of left shift operator over here. Now the key thing is there are a few bits and pieces here that complicate this issue, and that's why you see this if statement over here. So if two people called next at the same time, maybe two different microservices or two different threads, then potentially the timestamp could be the same over here, and you'd end up with two of the same IDs being generated, and those would not be globally unique. So then that's why this sequence property comes in. So if the last timestamp that was generated is equal to the next one, the next one that's generated, then we have to increment this sequence number over here and call get next milliseconds again, get a new timestamp and generate a new globally unique identifier. And then that's why we also OR this sequence into the calculation. Now you may be thinking, okay, that's great. I have an API now that can generate unique IDs, globally unique IDs. Now I have another data center somewhere. So maybe I have a data center in the US and maybe another one in London. And if I set the epoch the same to both of those, potentially both of those, they don't know about each other, the two data centers. And this code that's running in those two data centers could potentially generate the same ID as well. So the way we get around that is using these worker ID and data center IDs. So the data center 1 will, the one in the US will have a data center ID of 0, and the one in London will have a data center ID of 1. And now if we factor those two, the data center ID into the calculation, now we can have 2 different unique IDs generated each time. And then inside your data center, so in London, maybe you have the need to generate a large number of IDs. So that's what this worker ID thing is all about. You can have multiple instances of this Snowflake ID generator. So maybe in London, your data center ID is 1, and you have 1, 2, or 3 workers, and you give them unique IDs, and that way you can ensure that the workers are all generating unique IDs also, because that worker ID is factored into the calculation of the unique ID. Yeah, this class needs a bit of work, I think. So I'm gonna, I think it needs a lock around it. So if multiple threads are calling it all at the same time, that doesn't cause any issues. But do I need a lock? I guess we're gonna add this into an API in a minute. So ASP.NET Core we don't really need lots of threads or anything. So I think that's why I left it out. We'll come over here and we'll actually do a test that is actually useful. So we'll start with, let's start with a year 0, month 1, day 1. And let's start generating some Snowflake IDs. Let's do a for loop, and we'll generate 10,000 IDs. We'll generate the Snowflake ID, and we'll keep a tab on the last Snowflake ID. Potentially this is going to be null. Do I have nullable enabled in this project? Yes, I do. Implicit usings are also enabled. Use of unassigned local variable Snowflake ID. I guess I can make that null as well. To start with, and then we'll just ensure that assert dot how do you write more than again? Greater than? No. Is in range, not same, raises, single. I can't remember if XUnit has more than. It doesn't have more than. I can't believe it. Is in range. The closest thing is in range, but that's not what I want. XUnit is coming out with a version 3. It's been around for a long time. More than last Snowflake ID. If last Snowflake ID has value. So we want to make sure that the new Snowflake ID is a greater number than the last one. We also want to make sure true, Snowflake ID dot value, and we want to do u long is, how do you work out if it's negative or not? Is less than 0. Less than equal to 0. So we don't want a negative Snowflake ID as well. I think our year needs to be 1. And then we can get rid of that assertion there. And now we have a valid test. I wonder how many we can do here without overloading. Our test runner over here. So it's starting to take 2.5 seconds. If we do 1,000,000, that's 267 milliseconds. That's not too bad. So we want to make sure that we'll split this out into 2 different tests. Next is the function that we're calling over here that we're testing. We're not doing anything fancy. Does not generate negative 0 or negative ID. So we'll stick that there. And for this one, we don't actually need the last Snowflake ID. We can get rid of that. We can simplify this a fair bit. Use var. Don't know why var is not the default there. And in this one, we do need that, and we will run that assertion. And we will say rates sequential IDs. So how does that go? We can, what's the next test that we can run? So the next test we can run, I suppose, is to make sure that 2 worker IDs don't generate the same. We really need to control this date time and pass in our own one. So let's make some improvements here to this class. Whenever you have datetime.u or anything or .now, datetime.now, datetime.offset.now, or even the new .NET 6 date only.now in your class, you should consider moving this out into something that makes the class testable, because it's just not testable right now. And we'll do that by going public we'll create something that's mockable. Should we use mock, or should we just expose it? Let's just keep it simple. So we want to public func datetime get now UTC now, and the default is that implementation, but we can now do this .utc now. Why is that complaining? Oh yeah, it's a function. And since this is a function, we should probably call it get UTC now. And now in our tests, we can do something reliable. So if we go back and we have our date, we can go in here and say dot get UTC now equals, so when it does the now calculation, we'll just use the same date. And it's a settable thing as well. And now we can say assert dot equal zero UL. I'll give it that test a better name in a second. The actual one it generated was the number 1. Interesting. So if I say now equals, let's say the next second, 0, 0, 0, 1 millisecond. What's going to get generated here? Here we go. So we start with the number 1, and then the numbers start quickly escalating. So let's create a theory here. And so we'll get rid of this, and this needs to be a string. And this will be parsed from the string because inline data doesn't support zero, zero, hours, minutes, seconds, 1 millisecond, I think is the time I want there. Well, let's just do that. This needs to be a theory. Let's get some tests on here. The test method expected 2 parameters. Oh, of course. And we'll have 0 UL. There we go. We can finally generate some stuff. I think I'm getting the wrong date time value here. I always forget how to generate these date time values. So let me just go in here into C# Interactive, which I use all the time. That's generated 2001. That's weird. Let's say 0001. That's better. We'll just stick that there. It should be 1. Actual is 2. What's going on here? What if I do okay, that generates 2 UL. And if we change the number of milliseconds, .1 millisecond, I can't remember the syntax. Let's just make sure. Oops. That's 100 milliseconds. We want 1 millisecond. So we'll put some zeros in there. 0, 0. There we go. We got our theory. Now we're getting the number 1. That's weird. Not sure why that has changed. That should be the same every time now. That's gone back to 2. That's weird. Wonder what's going on here. This should be repeatable, and it's not. Ah, could it be because of all this funky math here? So maybe I can't do a repeatable test here very easily. Odd that. I don't know why it's doing that. There must be something to do with these left shifts that's producing different values. Each time it's run. Oh, we don't need this. Oh, was it because of the for loop? Why would the for loop cause that issue? Weird. Okay. So if we have something like, I don't know, 1 second instead of, what ID do we get? We get something that's progressively bigger and bigger. And then eventually we'll get to the point where if we go back to like a day old, we'll get to the stage where we get close to ulong.max. What is ulong.max value? That is the ulong max value right there. So how many numbers are we off that? So quite a fair bit there. But you'll end up with smaller values at the beginning, and then eventually you'll get to your ulong. Now there is an issue here, and that issue is time. You could end up, if I was to move 2,000 years into the future, you're gonna eventually end up with a point where you roll over and hit the end of time. So let's go to 3,000 years. I don't know how far I have to go. We'll go 9,000 years. And look, we've gone one bigger there. We'll go, I don't know, 100,000 years. And eventually we get a format exception, not recognized as a valid date time. Okay, so we've hit the limit. We can't go longer than that. So you can go to 10,000 years. So your application can run for 10,000 years before you run out of numbers to fit into an int64, which is not bad. So we'll just demonstrate that here with this test. I think, what was the biggest number you can do? Is it 99999? Actual is this number here. So that is very big. Let's expand this now. Default. So this is using the default worker, data center, and worker IDs. Now let's write another test that uses different worker and data center IDs. So we'll add some ulong ID. Did I write data center or with the, yeah, it's all lowercase, and a worker ID. Ulong worker ID. And we'll pass these in. So I actually don't like passing in a bunch of stuff like this. I'm going to switch to this options class that I created, and we will move a lot of this gubbins into there. Get UTC now. We've got our epoch, worker ID, data center ID, and our sequence ID. And can this be a record? I think it can. Record class. Why not? Let's make it in no. Can this be a record? I don't want to have to always specify these or this. Could default these. I always want to have to specify the epoch. So if I go date time epoch ulong worker ID equals 0 ul ulong data center ID equals 0 ul sequence equals ulong sequence 0 ul. So now I can get rid of these, and now I have, let's wrap these on to some new lines. So now I have my options. I can take my options in my class here, and I can move all this validation logic over to the constructor, I guess, of my options object. What happens with a constructor declared in a record with parameter list must have this constructor initializer. What? What's the solution here? Where's my browser gone? CS8862. I think a record is not a good idea in this case because I want validation. And it's hard to do validation. So let's undo all of that. Bring those back. Get rid of those. Keep the defaults though. And we'll bring in our constructor. And cut that. Paste that in there. Move. Oh. We'll take this as well. Stick that in there. I think the data center ID should probably come with it before the worker ID because a worker lives in a data center. And we have some max worker ID, max data center ID. We have some values here that we need. So we'll make these static. And we'll just call them from here. So we got our worker, we'll move this up here. And instead of 0, we'll go 0 UL. And comparison must be with a ulong rather than an integer. And the epoch can't be in the future as well, so that's a good. We should test this, write some tests for these. We'll do that in a second. And then we can finally pass in our options. And we can get rid of all that horrible code. And should I just store the options locally here? Public options get this dot options equals options. We want to, this is a new .NET 6 feature. This function throw if null. We'll just do that. And the old code written in Scala used to do some logging over here. I used to log what the options passed in were. We're just going to get rid of that for now. And we will get rid of these properties and we'll start using the options. Options.dataCenter.id, options.worker.id, options.epoch. Done. We've switched over to use options now. Let's go in here and fix our var options equals new Snowflake ID options, and we want our epoch. Should probably rename that to epoch, and we should always have the same epoch in all the tests probably. Does it matter? Static read only. We'll go with the default epoch. Can't type sometimes. We'll stick that in there. We'll add data center ID of, we'll stick to the defaults for the IDs. We want to default them 0 UL And that's our Snowflake ID generator. We want to override the get UTC now equals now. Why is this complaining? Now date time, there we go. Then we want to pass in the options here. We can get rid of this. That is a lot cleaner. And we also, that means we need to do something similar here. So we will do that. Pass in the options, get rid of that line of code. And here we also want to, we need to parse this. Now date time, data center ID, worker ID, sequence ID. We should pass in the sequence ID here as well for this test. Worker. Let's get that spelling right. And then the same for these other ones. So we don't want to override this for this one. Same epoch. This one is nice and simple. Cool. We have updated our tests. We'll give this a different name temporarily while we fix this. And now we need to pass in different IDs here. So we'll start with our first test. We'll pass in a data center ID of, why am I doing a theory here? What I really want to do is compare two different IDs with two different data center IDs. Yeah, let's do that. I want to compare two different generators with two different data center IDs and ensure they create different Snowflake IDs. So we'll create generator 1, generator 2, options 1 and options 2. And here we want the data center ID to be 0, and here we want it to be 1. And we'll pass in options 1, options 2. We'll just say 1 and 2 over here as well, just to make it nice and simple. We don't need, yes, we need this. We just want to do date time, new, we'll just go with new date time. Uh, 2001 will do. And we'll generate some Snowflake IDs and ensure they're not equal. So we have 2 data centers produce different IDs. And make it a fact. And we don't care about the worker ID or the sequence ID for now. Expected, not that, and the actual was that. So is our application just not working? Is our code just not working? We got data center ID shift So we got options 1, options 2. They should not be equal, but they are, which is not good. I wonder why that is. So if we go in here, in theory, maybe we should debug this. How are we doing for time? We're hitting 11 o'clock. Data center ID is 0. Oh, have we not set them in the constructor? Of course. Epoch equals epoch. This dot data center ID equals data center ID. This dot worker ID equals worker ID. This dot sequence equals sequence. So now, if I stop that, we should get our tests running again, and we have. Nice. So if we have two different data centers with different data center IDs, but the same, producing a Snowflake ID at the exact same time, they should produce different Snowflake IDs. That's good. Let's try the same thing now. Two different workers producing different IDs. So the data center ID is still 1 and 1. And now the worker ID is going to be 1 in this case and 2 in this case. That's working fine. And for the last one, we'll do we'll name these a bit better. 2 different data centers, 2 different workers, 2 different sequences. So in this case, we want the worker ID to be the same, and the sequence ID in this case will be 1, and in this case it will be 2. And they produce the same ID. So let's see what's going on with the sequence ID now. That shouldn't be the case in theory. What is the sequence ID for? Not ID. I'm saying ID too much. What is the sequence for? It's a good question. I don't think I set the sequence actually. This dot sequence equals options dot sequence. Now it should work. Didn't work. Why didn't it work? That was weird. Let's check this out. Let's debug that. I hate that you can't hit the debug button. From the live unit testing window. Here we go. So we got sequence of 0. That's not right. Oh, we reset the sequence. Interesting. We reset the sequence. This needs to be options.sequence here. I'm not even sure why this property exists. It was in the Scala code. Personally, I think we can just remove it. It will make life a lot easier and simpler. Let's stop this. Get rid of the sequence. And we can default to 0 again. 0 UL. Make sure we're using UL everywhere. This is using oh, but this is a long. We can't use unsigned long here because we actually need the sign in this case. Okay, that looks good. Let's go back to our live unit testing window. We'll get rid of this test because we got rid of the sequence number, and we have something that works. Excellent. So now we have our Snowflake ID generator. I was thinking we should put a lock in here to ensure that two threads couldn't get at it at the same time and produce the same sequence. But then I thought, if you've got two different threads, ideally what you should be doing is creating two different generators and changing the worker ID. So I left that out, and that will give you better performance as well. So I think it's worth it. Another interesting thing I'm just a bit confused about is we're using implicit usings here, and I'm still having to put using system into this class, which is odd. So let's quickly just see what's going on there. What using statements are we getting? If we go to obj debug.net 6, and I can't remember, here it is, id.global usings, global using system. So why can't I just remove that? And I can indeed. Don't know why it wasn't just an option to allow me to do that. We should also test some of these edge cases. So the validation logic here to ensure that these options are correct. And also there's a really funky bit of validation here. So what happens if all of a sudden your clock goes back on your machine and you generate another sequence and it compares it with the last one that it generated, the last timestamp, and then it realizes the clock has moved backwards? Well, in this case, we have to just throw until we can't do anything. The clock's moved back. We can't generate any IDs. So I guess that can happen if you're using daylight savings time, but we're using UTC, so there is no daylight savings time here. It could also happen in a leap year. Could it happen in a leap year where you have an extra day? No. Yeah, I'm not sure when it could happen, but if somebody manually changed the clock for some reason, this could be an issue. Cool. So we have our Snowflake ID generator now, and it's generating nice IDs for us. Nice simple integers, easy to parse. The IDs are sequential, so they go up in number, and we're not getting any duplicates as long as we set different data center IDs and worker IDs. And yeah, that's excellent. Let's finish with just validating this. Writing some tests for this, and this guy over here. So to start with, we'll create a new class to test the options. we'll call it Snowflake ID options test. And we should really rename this guy to generator test. And we want to rename that class as well. And I always keep my using statements inside the namespace. And over here, we want a fact class and for now we'll just keep that. So we want to test that the epoch is not more than today. The epoch must not be in the future. So we'll just do new Snowflake ID options, and we'll do a new, we'll go datetime dot UTC now dot add seconds 1, and we'll assert that that throws, whoops, what does it throw? An argument exception, out of range exception. You can hear my kids maybe in the background. My daughter's not well. She's came back from school having vomited. Not very nice at all. Feeling better today, but still not in school. Am I not using implicit usings here? Yeah, I should be. Implicit usings, we'll copy that here as well. Is packables false? We've got project references. I always like to have labels here. I always call this build settings, package references, project references, because I like to edit these manually myself. Keeps it nice and clean, and then we can get rid of that and make that. And we want epoch, we'll call this epoch is more than today, throws argument null, argument out, range exception. I use this syntax, so this is what we're calling. In this case, it's the constructor, so I just use the type name. What did we do in the test, and what was the expected outcome? And we'll write another test for the next one. The data center ID is less than 0. So data center ID less than 0. And we'll start with an epoch of, we don't care what the epoch is. Data center ID of -1. We can't do that because it's a ulong. So I don't know why I had less than that, because that's impossible. So that can be totally removed, that condition there. Data center ID can't be greater than or less than 0. We can remove that because it can't be less than 0. Data center ID, what's the maximum data center ID? Is more than max data center ID. I don't know what that is. Max data center ID +1. Should I just make that public? Yeah, let's do that. Public. People might want to know these, so I think that makes sense. Let's go back to our test. And now we're passing in an epoch and a max data center ID. If we do that, that should fail now. Yeah, didn't throw. I wonder what the max data center ID is anyway. And I'm just gonna create a quick test to check it. We'll do equal I don't know why I get this cannot convert ulong to string. Oh, that was because I forgot to add ul. That's right, it has to be the same type. The max is 15, so you can have 15 data centers. So let's go 16 here. I'm just going to put a number here so it's easy for people to see. And then too high, worker ID too high. We'll just pick 0. What is the maximum worker ID? Max worker ID. Just check that. 63. Undo that. And we'll go 64. You know what? I think I have these things the wrong way around. Because you want more data centers than workers in a particular data center. So I think this should have been 64 and this should have been 64 and this should have been 16. We'll need to fix that. If I go back to here and look at our generator, should probably swap these around. Max worker ID, max data center ID. What's the easiest way to do that? I probably should just rename them. So this determines how many bits each thing gets, and worker ID gets more bits. In the int64 than data center ID gets 4 bits. So it's got more space, and that's why you can have more worker IDs than data center IDs. Or have I got it right? It's a matter of determining what your scale is going to be. So if your scale is you're going to have 16 data centers all around the world, and in each one you're going to have 64 instances or 63 instances of a Snowflake ID generator, then this is the right way around. If you're going to have more data centers and less workers in a data center, then you can stick with this way around. So maybe we should make this configurable too, so you can swap around what the maximum should be. Sequence bits is 12. So you got 12 bits there. So you can generate a bunch of duplicates. You can have a bunch of snowflakes generated at the same time, and the sequence will keep incrementing, but eventually it's gonna overflow. No, is it gonna overflow? What's the sequence bits for? Worker ID shift. Oh, okay. Yeah, I think these should be options that get passed in. Let's make them options, because you may want to change them. So let's add public int and we'll keep the defaults. In fact, these should no longer have setters, because I'm passing them through the constructor and don't want anyone to change them after the fact. But this will have a getter and setter because I'm not passing it through the constructor. And here we will set the maximums. So we'll have an int worker ID bits. Oh, we'll do data center first. And the default there was 6. In fact, I can remove all these defaults here because I'm setting them in the constructor. And this will be six, and worker ID bits equals, was it 4? Yep. And we'll set those here. This dot worker ID bits equals worker ID bits. Cool. We should add some validation for those here. So you don't want a number less than 1. You want at least 1 bit, I think. And these should add up to 10. Let's just do that so that they can't be negative. No, stick to the initial type, I guess. Let's grab this and go like that. Data center ID bits is less than 0. If worker ID bits is less than 0, we want to throw argument out of range exception. And we want one more check to make sure that the data center ID bits plus the worker ID bits is more than, it has to equal 10. Must equal 10. If it's less, if it's not equal to 10, then we want to throw an argument exception, and we'll just say that worker ID bits must be equal to 10. Cannot convert from int to string. Oh. What's the param name? Param name goes set afterwards in an argument exception. Always check that. You can get it the wrong way around. And why do I have the wrong format here for the word ID? And I should probably stick this magic value of 10 somewhere in our generator. Const string max free bits equals 10 equals that plus data center bits. Probably put that below there. Oh, it's an int. So these are the maximum free bits. Someone at the door. These are the maximum free bits that somebody's allowed. Stick that in there. It's not max, is it? Yeah, we'll stick with that name. And now I should be able to set a different set of values here. So I need to change my generator to use those values. All of this code will need to move from this static down here. These will no longer be statics, but instance values. And worker ID bits and data center bits won't exist anymore. They're going to come from the options. Options dot those were integers. What did I choose over here? In those are integers too. Don't need the default there. Maybe this should go into the options class and the maximum free bits. I've made a bit of a hash of this. What's a good way to end? I think I'm gonna have a bit more of a play around with this, and then I will have some code in the next stream that will make these bits configurable. Because right now all of this, the maximum worker ID and data center ID, have to be derived from those things. Why does that complain when I just swap it out? These are constants. Let's move that over here. Make that 10. Maximum data center ID. Maybe we should make these. Move these as well over here. Max worker ID is a ulong. This dot max worker ID equals that. Worker ID bits. Why am I getting this error here about a cast now? Okay, I got rid of that. Max worker ID and max data center ID. Here we go. I think this is getting simpler now. Max data center ID equals that. And somebody's calling me on my phone, which I'm actually using to once I have this, I need this to move here because I only know what the max data center ID is here. Yeah, that didn't work, did it? I need a ulong here. We're having to do some casting, some funky casting somewhere along the line. Bits. If everything was a ulong, maybe this would play a bit nicer. The issue is we have some longs there and we need those. And we have max 3 bits here. So we can add that there. And then we just need to work this out. Why is this complaining when it's a constant? It's fine. So if I do const foo equals that, and did that, oh, what am I doing? Const data center bits. What is this? Along. This was an int before, wasn't it? So if I do that, let's move this up here. So if I just stuck this in here, that's fine because that's an integer. What type does it think this is? Int 64. So this expression creates an int 64. So this is an int 64, and what is it trying to make this? Int 64. Yeah, I'm not sure what's going on there. So this is a long, and we want to convert it to a U long. And it doesn't seem to like that. Oh, use unchecked syntax to override. That's what's the problem. So unchecked, I believe it works something like this. There we go. Can I get rid of unchecked? Yes, I can. I just needed the brackets there. Confused me. But I finally got it. And now if I go back to my generator, we can get the number of bits here from the options. You don't need these two anymore. The number of constants has gone down. We've got one constant there, sequence bits. Worker ID shift. Data center ID shift. Timestamp left shift. Sequence mask. I think that's it. I think we did it. Let's go back to our tests. Those are all running. This one's failing now, but because why? Do we have a build? Yes, we do. No exception was thrown in this case. And that's when we set a data center ID of 16. So let's debug that one. Why is that no longer throwing? Max data center ID is 63, that's 15. Oh, have I got this the wrong way around? Yes, I do. The default was the other way around. So it was 4 and 6. If I go back to live unit testing, everything should be green again. Good. All right, we're getting somewhere. All right, I think that's it for today. I'll finish up some of this testing here, write some unit tests for these, and maybe I'll write a unit test for this guy as well. Didn't get around to that. Next time, we'll set up a minimal API to return Snowflake IDs. We'll set up a generator within the API and get it to return some stuff. So you can find this code. Well, I'll post this code. I'm going to post this code in a public repo next time in the .NET Boxed Framework project. So we'll go over here to the framework project. We'll go over to, I'll create a pull request over here very soon and stick this code in there because I want it to be publicly available. So people can use it because I'd like to use this myself. So catch that next week. Oh, I also had some more updates on .NET 6 improvements and things that we can make. Some more secret features that were added. I discovered them from watching the Twitch stream that Damien Edwards and David Fowler did. So I'll probably cover that as well in next week's stream as .NET 6 gets released. So we'll do that next week. So thanks everyone. If you want to catch me on my blog, you can go to rehansaid.com. Ping me any questions you have on Twitter at rehansaiduk, and don't forget to like, subscribe on the YouTube channel. Thank you.